Well, hi, good morning, and thanks so much for joining me and Shadow here in my shop. I'm going to get ready to do the alignment on process on this radio, both the IF and the oscillators and the RF alignment. We'll do the whole shot. Excuse me. Oh, no. Not coronavirus, not to worry. So my cat's here to help. I don't know exactly how that's going to work out. First thing we want to do is get this set up, get some connections made to it, get a signal fed into it, and get it ready to do the alignment. Hey, Shadow. Come on, let's go watch some TV. Okay, let's get this radio warming up here. Good show. Now, I did do the IF alignment. What I found my first time through it was that it seemed to be pretty close. Not really a serious problem. Probably is the case, but I had some capacitors missing while I was doing that, so those capacitors aren't missing anymore. What I discovered very quickly was if I take my typical alignment tool and try to use it in here, well, it was a big problem. So to get around that, eventually what I chose to do, since I have two of these, is cut one in half. So I snapped this one in half. I then struggled with this short end for quite a while until I concluded that I just didn't have the leverage. There's no handle, it's just a thin little thing. So I just wrapped some tape on it to build up the handle, and at that point this became a functional tool. And so, good show. I've got all this figured out. This took quite a while to figure this stuff out. I guess I'm a little slow these days. So, good. Let's listen to this radio and make sure it's actually working. Before I start, so we'll go band 1. Certainly sounds like it, doesn't it? This antenna, I don't think it's switched down here. I hear a voice. That's okay. I'm reassured the radio is working properly. Well, maybe not properly, but it's certainly working enough. Okay, so we need to have a signal fed into the radio. In this case, they suggest it be put into the stator plates on the non-oscillator part of the tuner. And you know what I just realized? My gosh, this is probably why maybe things didn't go quite as well as they could have first time around. I don't think I'm on the right connection. So there's two sets of capacitors in here, two tuning capacitors, if you like. One is for the regular tuning, and the other one is for the band spread. And I think I've hooked that capacitor, that yellow capacitor, you see, to the wrong one. And I must have done the same thing last time around. I'm sure that's not helpful. So we're going to pull it off there. Now I got a radio full of hot tubes. I'm going to try to put it on the proper spot. Oh boy. That's the thing about making mistakes. You don't know you're making them. Okay, barely on there, but it's on there. Good. Okay, so what we'll do is we'll bring this guy up. Don't I have a clip? Here's one. There we go. So this I want to go on to the B minus. Now if you look at the instructions, under step 1, It says high side through a .01 microfarad capacitor to the stator plates of the front section of the tuning gang. Oh, okay. Low side to the chassis, so okay. Tuning. I got it in the right spot. That's what the capacitor is. Low side to the chassis. So we're going to try that. I think we're going to get a huge hum out of that from my previous experience, which is another thing I spent quite a bit of time on. So we're going to hook up to the capacitor here. Let's get a little volume on the radio. Not that much volume. Okay, now if we hook the ground side to the chassis, everything's fine. You know what? Maybe those capacitors were missing. That could have been it. The capacitors that I'd left out resulted in me having horrendous hum problems doing this kind of stuff. Yes, I wasted a lot of time hunting down stuff that was my own fault. Okay, now we need to see a tone. So let's tune the signal generator in here. Douse the studio lights here. Well, I didn't hear anything. Oh, so I don't have any modulation on it right now. So put on the modulation. Thirty 30% modulation. There, you can hear it going by. Just put a little more volume. Now I want to get this meter showing up. My meter has a number of switch settings here. Some of them are very stable and some of them are not. So when you see me viciously turning this thing, trying to find a nice stable spot. That's not one. Here we are. This is good. This is good. Very good. Now I'm going to double check that by changing the modulation level just to be sure the meter is reacting to the tone. Yeah, without a doubt. Excellent. So we got an excellent test setup here. Now there's two IF transformers. There's a top and a bottom. And what's it say in the instructions? Let's see. Oh, I was reading stuff you couldn't see. Whoops. Let's just run down this first part. Amplitude modulated generator 4, 55 to 30 megahertz. Modulate output every step at number 2. Oh, it'll be interesting to do number 2 again. Connect output meter across voice coils, did that. Use non-metallic alignment tools, doing that. Set AM CW switch at AM, did that. Speaker switch at speaker, yes of course. Volume at maximum, no way, you think I'm crazy? Receive standby switch at receive. And band spread control at 0. Okay, let me just make sure the band spread is at 0. Okay. Dummy antenna, we don't need it yet. Now this is what I read that you couldn't see before, where it says connect the capacitor to the section of the tuning gang. That's what I was saying. Put it in bold print there to stop people like me from making the mistakes I made. There you go. 455. Band selection is 1. Receiver dial setting in the middle. Okay, I'll put it in the middle. Let's see the radios. Picking something up with no antenna. That's pretty good. We'll use that spot right there. A, B, C, and D for maximum output. Keep reducing generator output so reading on the output meter does not exceed 50 milliwatts. Do we really want to try that? What does 50 milliwatts sound like? Well, that's interesting. Now, I don't usually use this meter that way. Let's see if we can figure this out. 1 milliwatt at 0. So it's decibels. 1 milliwatt, 600 ohms. So I'm pretty sure that means 0 on the meter is 1 milliwatt. 0. Yeah, you know, I don't know enough of what. I'd have to read up to get this correct, so I'm not going to bother with it. Hey, what happened there? Where that just... What's going on here? Is that... What in heaven's name is that? I'm not moving. Okay, I'm going to start moving some stuff here. It's most likely this. I said something, I warned you about this. That it might come down to some crazy stuff here. There we go. We're going downhill here. Now there's one scale setting that is absolutely reliable. Oh man, I tell you. I don't want to listen to that. That's blowing my ears off too. This is the problem here with doing this. You gonna sit there and be stable now? Okay, let's double check once again with the modulation control and make sure what we're seeing is the actual tone. Yes. Okay, now we want this to be set to 455 up here. Oh, wow, I'm way off. Better turn this down because it's going to get louder. So I'm watching the meter here. Our peak reading is happening at 453. 455 is my counter reached just a touch low, so that's extremely close to 455. Now, I'm going to move this up just a wee bit. Come on, meter, don't be doing this. Don't be doing this. Who's responsible for that? Oh, we're crying out loud. And before you say, well, why don't you clean the switch? Well, that switch has been cleaned 6 times over the years. Look at that. I can't do the test like this. It cannot be done like this. Oh, you bum of a meter. I really want to use that meter, which is why I keep trying. It's my perpetually optimistic nature here. Okay, we're going to use the old one, which is wonderfully reliable. Just let it settle itself down. Now I'd have this meter sitting in my bench position there, except look, it's just 1 inch too tall to fit under the... Yeah. So, okay, all meter problems are gone now. There we are. There's no question about it. It won't get thrown off. Okay, once again, verifying the tuning of the signal generator. No, I don't have to verify it. I want it there for time to start twiddling those tuning controls, and it's really awkward. We don't have to look at the frequency anymore. It's going to stay what it is. what's awkward is getting your hand in. So I really committed to not taking the chassis out on this radio. Just getting your hand into a strong position is a big challenge when you're doing this stuff. I think it's got to go in this way. Okay, I got it. I think I got it. Oh boy. No. Okay. Up, up. Up, up, down. Okay, got it. There we go. That was a tough one. We'll do the bottom of that one. There we go. Watching the meter. Down. Down. See, I got these lower ones done pretty correctly, but the upper ones are driving me nuts. Okay, let's do the other upper one. Uh-oh. Uh-oh. Clip's gonna fall off. Okay, we're in. Watching the meter. Down. Down. So this is right on. I got this one on. Right there. And the bottom. Okay, ready? Up, up, down, up, down. Just off by a touch. Okay, so that puts the IF at 455 without much doubt. Now, if we take a look at the instructions, we go on to the next thing. Same as step 1, no modulation on the signal. Set the AM CW switch to CW. Don't forget, they should put this in bold for me. Hey, don't forget to reset it or you're going to be screwed from then on. For correct BFO operation, vary the coupling between lead E pins 4 and 8 of the 12 SG7. Now, these instructions cannot be applied to this radio because this radio's BFO is done differently. It's the same concept of a wire, like a controlled accident, a wire conveying a signal through the radio. Maximum beat note, push lead E towards pin 4. So, didn't have any luck with this before, but I'm going to try it again a little bit. I think I put a video up on this, and it was just me kind of exploring this thing. So let's try this. So, everything the same, no modulation. Okay, no modulation. And we flip the button on the front. Oh, that's interesting. Sounds quite different. Now what are you supposed to do with that? Vary the coupling for maximum beat note. Pushing lead E towards pin 4. Maximum beat note. So, well, something has happened, but I don't hear a beat. Let me vary the frequency of the signal generator here. Let's see if we get something different going on. Just a little bit. Oh yeah. Listen to that. Now if I turn off the BFO system here, How do you like that? Now, is this really, you know, I did read on the internet, people think this is kind of a goofy way of doing it. It's almost like a single sideband in a way, sort of sound. There's no going up the other side. That's pretty interesting. We would have to actually tune in some real ham radio single sideband and then use that to try to clarify it, find out if this works at all reasonably. How else could I do it? How else could I do that? How else could you be sure it's good? And what if it isn't? I'm gonna wiggle that big wire that runs through the back there. I really don't know what kind of adjustments could be made anyway. So let's see. We've finished with injecting the signal into the IF, so I can disconnect that part of the equipment. We can flip the radio around, put an antenna on it, try to pick up some ham radio guys, and see if this thing really does clarify them. It's quite a challenge to pick up ham radio stuff at this time of day. Sounds like something worth doing. Let's do that. Does the BFO really do the trick? Okay, so so down on the volume before I get my ears blasted off here. Pull that out. There it is. Take that off. Okay, we'll bring on the antenna. I'm going to have to run and throw the switch on the antenna. This is the antenna. This is the antenna lead. That's good. Okay, so I have to go down and toss, throw the switch. Be right back. Go. Yeah, I've been listening to shortwave every night just for a little bit. Okay. Wow, well that really sounds like a BFO, doesn't it? Let's see if we can spin this around so we can see what we're doing here. Okay, BFO thing off. Switch to shortwave band. So we're on this band 5 to 14. Up around 14 we might find some stuff. So let's tune up there. Once again, that signal just comes out of silence. It's fantastic. Okay. Now, so I don't hear anything. I think the receiver is pretty insensitive up here. Yeah, I don't think we're going to pick up any ham stuff. So if you have a BFO on and you have a regular station playing, the BFO and the carrier signal of the regular station will generate a difference frequency, and as you tune the station and move the carrier frequency around a little bit in the IF against this weird BFO oscillating IF system in here, you end up moving two IF signals close together, you get the beat frequency and can hear it. what we should hear as I tune through one of these stations is a high-pitched tone come down and then go back up and disappear with the BFO on. So where's the station again? Here's one. Okay. BFO on. There it is. This is a fantastic lesson right here. This is being done by accidentally feeding back the output of the IF back into the front end. That's how I think they're doing this. So they're causing the IF to oscillate. And it's oscillating at 455. You can't hear it, there's no modulation, but it's happening in there. Then when you bring in the tune signal and its product, 455 product, crosses the oscillating IF. I've had lots of radios in here that I've worked on and have this problem in them, where as you tune through a station, you hear that. It's the same effect. It could be the same kinds of problems going on in some of the radios that I'm working on, accidentally. So what has happened here is the smart engineers who designed this, after encountering this accidental IF feedback problem and dealing with it over and over and over as they designed their radios, somebody said, hey, wait a minute, we can use that and tell people it's a BFO. So I'm teaching myself right now what this sounds like. So I'm tuning in partially and listening to the kind of sound and saying to myself, this is my chance. I know what's going on in this radio to realize what's going on in other radios. This is a breakthrough moment. So I don't know for sure that that's what this does. It sets up an oscillation in the IF that beats with the signal you're tuning. I think that's how it operates. And I don't know how else it could. There's no separate oscillator in here to generate a BFO. BFO oscillators are usually a separate circuit providing a separate signal. Okay, so that's cool. We'll go back here and carry on. So the next step is to twiddle all these adjustments here. Yeehaw! Just a minute while I put on my confusion hat. Get ready for this. I'm wearing the confusion hat quite regularly these days. And maybe this is happening to you too. All day long now I'm peppered by little tiny snippets of news, none of it particularly good. And I'd be stupid to think I'm not being disturbed by all these things that are going on. As much as I like to think I'm not being disturbed by it. Okay. Yeah. Let's read the book. Read the book. Stop being disturbed and read the book. So BFO adjustment, no, we don't need to adjust anything. RF alignment. High side through RTMA dummy antenna to terminal A1 on back chassis, low side to chassis. Connect jumper between A2 and G. What? Jumper between A, huh? Oh, what am I talking about? That's on the ground. That's a ground jumper. Link. See, they should use the word link there. I'd be better off. High side through RTMA. What is RTMA? So what are they doing here? So you take the high side of your signal, pass it through this guy. Are you kidding me? 20, come on, really need all this? What? What is all this trying to do? 400 ohms. 100 picofarads. 400 picofarads. So you have a capacitor and an inductor with a resistor. I don't know. I don't know what this is up to. Oh my gosh. Well, let's see. Usually you're putting these things in, so the radio thinks it's connected to a regular antenna, a typical antenna that it would be connected to during regular operation, not a piece of equipment. So this is a fooler circuit to fool the radio. If it's a good one, at the same time, you're fooling your piece of equipment into thinking it's connected to something that's happy to have it connected there. The output of my signal generator is 50 ohms. The input to this radio, it's meant for a long wire in this arrangement with the link in. Long wire impedance presented to a radio is 200, 300, 400 ohms. 400 ohms. So you need 400 ohms in series. So that would make, so assuming, let's make an assumption here that this is, what is this doing? This has to be active. It has to have reactance in it for it to be doing something useful. What? You know what this is doing? I think I know what this is doing. As you vary the frequency of the signal generator, you are varying the apparent impedance into the radio. I think, because of the circuit and its differences as the frequency changes. So again, you're trying to imitate what is going on with an antenna, I think, as you change frequency, because the frequency range in this radio, and it's all the way from on the wire antenna, it's all the way from the bottom of the AM band way up to 30 megahertz. That's a phenomenal range. So I'm going to take a wild guess here. I'm just guessing at this, that the lower frequency, a long wire antenna provides a lower impedance, and at a higher frequency it looks like a higher impedance. And this circuit is designed to do that because the signal generator doesn't change. The signal generator is designed to present 50 at all frequencies. A good one anyway. And I have a good one. So that's what this has to be. This has to be a frequency impedance changer trying to imitate the frequency effect as you range over this radio all the way from what? All the way from 30, you're doing tests at 30 here, all the way down to 600 kilocycles. It's a huge, huge range. So now if that's the case, why wouldn't I say, well, I don't want to do this. Why don't I make two of these up? Make one with a 400 ohm and one with a, I don't know, 800 ohm resistor. Drop the coil, drop half these capacitors, just use the resistor. And just change it as I go high and low. I don't know which way to change it. Is it even important, for crying out loud? I do a lot of this stuff. I don't even bother with this. You know, I don't bother with it precisely. So why would it matter if the signal intensity is varying as you tune up and down the band during this process? At what point would you become confused about something? Because everything's done at one frequency, right? You tune everything at 14 megacycles, you do this. And it's all relative. They aren't giving you values here. Make sure the output is 45 decibels. They're just maximize it. It's all relative. Okay, so another thing is, maybe a really fiddly engineer wrote this, so that's why that's in here. Another guy would have said, oh my god, I just stick a resistor in there, for crying out loud, it's good enough. So communications receiver, it's at very much the low end of communication receivers, that's for sure. So maybe the communication receiver engineer is just a little fancier kind of guy, likes a fancy thing here. RTMA. Maybe it's written up here. What the heck does RTMA? RTMA. RF something alignment? RTMA. Come on. What does RTMA mean? I'm going to find out. RTMA. Let's go find out. RTMA dummy antenna. What are the chances? RMA. Okay, so RMA, Radio Manufacturers Association. Dummy antenna is a simple device. RMA dummy antenna consists of a .02 in series with a 20. Hey, look at this. Normal load. Why use a dummy antenna? Man, it might be smart for me. Here we are. Look at this. Right here. Hallicrafters RTMA dummy antenna needed for alignment. Let me put this up on the screen fully here. Hang on 1 second. Okay, and who's saying this? The mailman. Let's go read what the mailman has to say about this. RTMA dummy needed for alignment. You know, aren't I the dummy? I'm the dummy. It depends on the TD balance whether or not it will make it down those balance. What's he talking about here? This article. 4-to-1 matching is not perfect in my experience. This has nothing to do with RTMA. If the input coils were designed for a high impedance antenna and a low impedance generator was placed across them, then the excessive loading would give erroneous readings. You can notice the effect when using a coax-fed dipole. In many cases, the signal drops rather dramatic. If the dummy load isn't available, misnamed since it is an earlier attempt at a broadband matching device. That's exactly what I was thinking it was. Yes. Isn't available, then wind to 9-to-1. Oh my gosh. Old TV balance are pretty much useless. Yeah. Accurate readings. What readings are they taking? We're just doing a comparative or a qualitative adjustment. Absolutely. Okay. So I think what I am going to do here, I'm not going to sweat over this too much longer. I actually have a specialized dummy antenna for this signal generator. He says I'm looking for it, and here they are. Attenuator, impedance adapter, antenna simulator. Now, I'm going to put this in the circuit. I'm not going to think too much harder about it. And we're going to hook it up to the radio and I'm going to align it. And that's how this is going to go. Provided I can find the connector I need. Son of a gun. There, I found it. The whole thing is overkill, I think. Should take a little look at the schematic here. I think there's enough on the window there for you to see it. Let's go here, and if we look at the input coils here, and we ask ourselves, what happens to these if we hook up stupid things to the antenna? Okay, I'm going to just move this down for a moment because it's kind of chunky. So just look at that. So ground with a link over to A2, and then the antenna's on A1. Let's just study this a little bit. Look back up. So we're only going to be working through one set of these coils, so we'll just pay attention to this set here. So down comes the signal, selected onto D in this case. Signal goes through here, comes back up, off to the other side. So there we are. So this coil is energized. So what if I'm feeding this with a low impedance source? 50 ohm source. I think what they're trying to say is that will change the resonant relationship inside this transformer. And if you mess around with these too much, you'll whack this guy out too much. I think that's what they're trying to say. So they're trying to do everything they can to make this look like a wire. So why wouldn't we just stick a wire out the back here and then try to impress the signal generator onto the wire without actually connecting to it? Why wouldn't we try that? We could try that. Wouldn't that be even a better solution? Probably not, because if you're doing careful measurements and you're trying different frequencies and you think things are stable between frequencies, they probably aren't even then. So I guess that's kind of a way of looking at that antenna thing, that it's a stabilizer, so you can whip around from frequency to frequency, and what you're seeing, hearing in the output, it all makes sense. Why do we need that for fixed frequency alignment? So this is tuned with the tuning capacitor, or is that a trimmer? That's just a trimmer. This is the tuning capacitor. So if you whack this out by putting a stupid impedance out here, you'll then adjust this incorrectly. And you maximize this thing at the wrong spot. So I lay a piece of wire out here and impress on it. Like, how far out can it be? In a single frequency situation, this circuit is being affected by what it would be affected by anyway, a piece of wire. Might be interesting to hook this up to a long piece and a short piece and see what differences it makes here. Along the way, sensitivity probably only at the highest frequencies. Probably criticality at the highest frequencies. We got a band here on this radio that goes all the way from 13 to 30. And that's a long ways. Even the other band, 5 to 14, that's a long ways. Well, I'm going to start by trying. I'm going to start by trying. I'm going to lay a wire out here, lay the signal generator up near it, and just try to impress a signal into it on the basis that that is also an effective way to do this without disturbing this guy. And then I don't have to make that circuit. You know, it would have taken less time to make the circuit than it is for me to talk my way through not making it. Okay, so I think I've talked my way, talked my way into doing something easy here. I've talked myself out of the hard way of doing it. So we want to take off this antenna here. We want to put on the signal generator. It's on the other side of the adapter there. You can hear it a little bit. Oh, it's still at 455. Is that what we're hearing? No. What are we hearing? Why is there a tone coming out of this radio? So this radio is receiving this with zero antenna on shortwave. Zero antenna. How the heck can you do that? Wow. Wow. It's receiving it on little bits of wire in here. Receiving it through the power cord. Can the power cord act as an antenna? Radio Cuba, I think. Yeah, I don't know if I can't prove anything to that. That's amazing. So, wow, sensitivity galore. High sensitivity, low noise. How does this radio do this? He says with a curious tone in his voice. That's kind of what we want. Well, it's obvious doing that completely alters the front end of the radio, because listen how quiet it went. So now, if it's still on the station, if I just throw on a piece of wire here, let's just try a short clip lead. What a radio! And we take the, just try this silly arrangement here. So what I'm doing is I'm just wrapping them near each other. Tune off the station. We're up around 9 megahertz. 9.95 or somewhere like that. More power. You know what? I got to tune the radio differently because it's right on the band change of my signal generator. So let's put this up in frequency. So up around 11, I think. Put on the modulation. Okay, so a couple things here. First, I don't need this isolating box here. It may be cutting a little bit off. A little more signal to make this work. So it's coming through now on the radio, nice and low. Make sure it's doing it through this wire. Yeah. So reduce it. So I think that qualifies pretty good. That's a low-level signal going into the radio. I think it's very good for alignment. We started what, 30 megacycles on that band. Okay, switching bands. Band 4, 30 megacycles on the dial. You know what? I bet you we can't get this to come through. I think the radio is so weak up here. 30 is right on the band division again. Maybe my signal generator can't even get up there. Good, we go right on by 30. I didn't hear a thing. Turn up the radio. think the radio is so insensitive that it's really going to have trouble here. So I'm going to forsake my technique here a little bit. I'm going to hook this output of the signal generator without a ground connection. See if we can hear that. We've got a pretty darn good hum out of it. Let's do this then. That doesn't even kill the hum. There we go. Humming. We're humming again. I'll try this on B minus. Yep. Okay, now we're hum free. Now I can blast it. I am blasting a whopper of a signal into the back of this radio. Let's put it like that. Okay, we're tuned to 30. Wow, 0. Oh, I can go up higher yet. Okay, now we're blasting a whopper. I think I found it. Turn down the radio. Turn down this. .6, and it's pointing at 30 at the bottom scale there. 5 megahertz off. That's a little out. Let's look at the other end of the band here. It's much worse than I would have expected. I'll go in the middle. We stop in the middle at 20. Okay, and dial it right in on 20. Is 17.8. 15. Okay, I've dialed in on 15. So without actually looking at the numbers on a piece of paper, it looks to me like the air is smaller at the low end of the band, and then as you go up, the air gets bigger and bigger. Oscillator alignment problem. Let's do this on the other band. Just get a feel for this radio here. There's a mile out on this one. Okay. So this band goes from 5 to 15. So since we're up 15 here, let's go up there. Anytime now. Okay, didn't show up. Okay, so I'll tune this to 14. And we'll find it with this. Oh my gosh, 14 is actually 14 is actually 12. That's 2 of them low. Let's go to the other end. Oh, stop in the middle again. Stop in the middle at 9. Half a 9? Half a 9? Maybe that's something coming out of my signal generator. So it's actually 8.2. Okay, let's go down to the bottom band here. I think we heard the image signal go by. I'll put it right on 5 megahertz. Now we're on the other side. Or are we? No, we're not. So that's the image. The real McCoy. Let's turn this down a wee bit. Okay, we could pretend that's a pretty typical station. What if we take a typical station strength and put it at the location of the image? Still hear it. Yeah. Okay, so that's a quick image check. Not so good. And is it worth doing that? Let's just keep going. Let's do the low band too. So now we're on 1.7, or just above the AM band, up to 5 megahertz. Not much in here to listen to normally. So we're down at 1.7. So that's pretty close, kinda. 7. Now we'll go up. Sounds great. Sounds like a radio. Okay, 3. We're at 3 megahertz now. Low again. Yeah. That's in the middle, and then at the top. So this radio is saying, please fix my oscillator. It's just 60 million miles out. We're at 5 now. So with the radio dialed to 5, we find the image at 5. Here's the real signal at 4. We're up near 5. Ooh, that kind of hints somebody aligned this on the image. Wouldn't bet on that. What I would bet is this radio's just never been aligned since day one, and it's drifted off. Okay, so that shows the oscillator situation. Now, I'm going to guess one of the banks of these is the oscillator bank. This is very clever how they've done this in this radio. This is a tour de force of saving money everywhere. They made this great big coil form in here, and then attached to these trimmers right to the coil form, right to where the coils are. It's extremely efficient. You could build these coils outside the radio, and then in they go as an assembly. Of course, that's how they would do it. And then there's one more out here and one more here. It's a 4-band radio. You'd think there'd be 4. There's 3 here and 4 there and 2. Okay, well, it's going to be apparent in the instructions. Let's look through them. F and G for maximum output. So F and G. So what are they talking about here? There's F, and there's G. Band 4 antenna, band 4 oscillator. So this tells you what everything is. Very good. Great. This even tells you A, B, C, and D. I didn't avail myself of that on underside of chassis, right? That's okay. We're good. F and G for maximum output. So F is the oscillator. This is the one that we want to really concentrate on. Oh, I'm sorry, I'm not putting this up on the screen properly. When I look at my computer, it's an entire screen, so I'll try to remember to move this stuff to the top so you can see it too. So here we are. F and G, band 4 antenna. Alright, and if you've got some fakey antenna like I do, a clip lead or nothing, or a signal generator, then this adjustment won't go well. Why couldn't you do this adjustment on a station received from an antenna rather than try to rely on your oscillator? I think you could. I think you could do that easily. I think that'd be a better way to go. Okay, so concentrating on just oscillators. Let's just do oscillators only on all bands. We'll just do that. So I'm going back up to the 30 to the top band. Okay, and dialing in 30 megacycles because I can. F, and we'll just that's it. Okay, right. And we'll do it now. The oscillator cannot be thrown off by this antenna connection of the signal generator. It's the antenna tuning that will be thrown off. I believe that. So I don't think there's any problem with having this kind of crude connection right on here. So we need a 30 meg of 125 to start with over here. .25 because that's what the radio is going to respond to. And right on 30 on the dial. I need an adjuster. This will probably do. You know what? I need a bigger. I need a metal screwdriver. We'll try that first. Modulation's on. Signal's fairly low. Why don't we should hear something? Turn the volume up. Volume's up. Power up. Down. Okay, so with the radio saying it's on 30, it's actually receiving 25. Well, first thing we got to do is figure out which way to turn the screw. It's this screw. Oh boy. Yeah, I don't think I'm going to be able to use the metal. Oh. No, it's changing it. Let's try this one. It's changing it. Let's try the plastic again. Won't go in. Okay, here we go. Let's find a great big honker. That's good. That's good. This is nice and stiff. Okay, we're ready. So move this in the direction we want to go. Not too far. So you can still hear it. Now we figure out which way to turn the screw here. I think it was this way. So we'll turn it a fair bit. Now we'll see where it is. Come on, did I go the wrong way? Let's try that again. Tightening and looking. It's going the other way. Okay, so we'll move this up to... Got a long ways to go. I don't think we'll ever get there. 26. Yeah, don't turn the wrong one. Get this guy to sing at 26. Loosening. There it goes. Keep going. Where did we get to? 26.6. Put this up to 27. See if you can find it. Man, it's a long ways for a trimmer. There it goes. Keep going. Okay, so we're heading for 28. I think I heard it go by very faintly. More power. Did I tighten it there by accident? Loosen it right off more. going on. We're getting something here. I'm getting something here. That was about a megahertz, I think. So that's so wait a minute. Okay, so on these radios, the local oscillator can be above the target frequency or below. Let's put it this way: the designers intended it to be above or below, and you can easily align it the wrong way. That could be what's going on here. Is there a hint on that? Is there a hint on that? Might be up here. Occasionally they'll say, you know, local oscillator below. Sometimes I'll make a note. Only do number 2 only. Look at that. Only if a weak beat noticed. I just don't think there's going to be anything in here. Won't be down here. Okay. So they're not telling us. So I'm going to find out. I'm going to have to stop. I'm going to put the local oscillator, make it visible on the SDR, so we know what's going on. Well, you've been watching the video I've been working on right up until this point, and I'm kind of jumping in and saying what comes next in this video I'm going to carry on with tomorrow. What comes next is I pull out my SDR radio and I start messing around with it and trying to find a local oscillator, and quite a number of issues come up. Confusion reigns and there's no resolution. So tomorrow I will start with the confusion, and I'm just going to keep my head in it until I understand what goes on in these radios and my SDR when I'm doing that kind of testing. Because well, it's really interesting. So I'm going to say goodbye now, but I will leave a little bit of SDR video at the end of this video just for you to look at some pretty pictures. Thanks a lot for watching, and tune in again tomorrow. See if I sort this thing out. No, that can't be it, because I'm tuning up and it's going down. As long as I'm tuning up, it has to be going up. It can't be going down. And look at that other one standing still there on the left side of that. What is that? No other signal generator going in here. Okay, one of these has to be going up. Okay, I'm tuning upwards. What is going on? They're all heading for that. Holy smokes, here we go. I can draw some pretty pictures on my SDR here. So I see patterns like this regularly when I'm doing SDR work with radios. If you've watched a lot of my videos, you've seen stuff like this. What exactly is going on here? Idea. So this frequency in the middle, what's it sound like? Oh, jumper. Now that's the SDR you're listening to. What is producing that sound? My gosh, such a pure tone. Let me tune the radio a bit. You know, understanding this fully, I think, is an important step forward for me personally. Yeah. Where's that tone come from? Let me change the tuning on the SDR just a little bit. It went up in frequency. So why is the frequency changing as I tune past it? Why? So that sound, when I have the radio tuned such that that image becomes like that, lunchtime.